We experience the AI revolution through our screens as a purely digital phenomenon. But behind every generated text and image is a massive, highly physical network of machines that powers on to process the request. Building that physical network has triggered a historic wave of capital. In the last 6 years, tech giants have committed more money to data center construction than the entire Marshall Plan used to rebuild Europe. The spending exceeds the total cost of the Manhattan Project. It eclipses the entire Apollo space program. In fact, the capital deployed into AI infrastructure surpasses all of those combined, with enough left over to fund the International Space Station. This historic spending spree is driven by a single assumption, heavily promoted by industry leaders like Sam Altman. Raw computing power directly dictates how smart an AI becomes. If you want better models, you must build massive data centers, and you must build them right now. Following this logic, Wall Street has priced in exponential growth. By 2026, just 4 major tech companies are projected to spend $650 billion in a single year on new facilities. But digital financial projections are colliding with the physical limitations at ground level. These facilities require immense tracts of land, thousands of tons of concrete, and massive industrial supply lines to materialize. The reality is not keeping pace with the ledgers. Nearly half of all data center projects planned to open in the United States this year have already been delayed or canceled outright. Only a third are actually under construction. Before the next generation of AI software can even be fully deployed, the physical foundation required to run it is fracturing under its own weight. A decade ago, the number of dedicated AI data centers in the United States was essentially zero. Today, this map shows how the industry has aggressively multiplied, placing over 5,000 facilities across the country. The scale of these new sites requires a new metric. Tech companies no longer measure power in megawatts, they use gigawatts. A single facility currently under construction by Meta in Louisiana is on track to draw 5 gigawatts of power, an amount equal to the average demand of the entire city of London. Modern AI chips draw significantly more energy than standard servers. The grid cannot simply generate gigawatts on demand. As a result, around 25% of data center projects slated for 2026 have no viable source of electricity secured. Even when power is available, the hardware to route it is missing. To connect these sites to the grid, developers require massive, specialized equipment, like high-power transformers and heavy-duty switchgear. The United States cannot manufacture these components at the required volume. Developers rely heavily on imports from China, which surged from 1,500 units in 2022 to over 8,000 recently. Now, tariffs and geopolitical friction are choking that critical pipeline. The specialized workforce needed to wire these facilities does not exist at scale. Tech giants are now setting up free, ground-level training programs just to get enough bodies into trenches to splice fiber optic cables. The tech industry designed software algorithms for infinite, frictionless growth. They are now discovering the strict, physical boundaries of global supply chains and local power grids. The constraints of those grids are spilling over into the surrounding communities. Residents living near these mega campuses are reporting heavy sediment draining into their aquifers, intense heat venting into their valleys, and the constant exhaust of tens of thousands of backup diesel generators. While developers secure massive property tax abatements by promising economic revitalization, the reality is starkly different. A completed megacenter typically employs fewer than 150 permanent workers. Local municipalities absorb the heavy infrastructure wear without receiving the corresponding tax revenue. The financial drain is highly measurable. In Oregon, public schools recently lost out on an estimated $275 million in potential funding directly because of data center tax exemptions. The sheer cost of upgrading the electrical grid to handle these facilities is often passed directly to consumers. Utility providers in Georgia raised residential rates 6 times over 2 years, resulting in a 24% spike, while parts of Oregon saw consumer bills jump by 50%. Communities are mobilizing against further development. Recent polling indicates 65% of Americans now oppose data centers in their towns. The pushback has reached the legislative level, with states like Maine passing outright bans on new construction until at least 2027. The friction has escalated to the federal level. The FBI recently classified organized anti-data center protests as an emerging domestic threat, placing local resistance on federal watch list. Hyperscale tech companies are attempting to bypass the physical limits of their expansion by shifting the environmental and financial burdens onto everyday taxpayers. These localized physical failures are creating a highly concentrated risk on Wall Street. With construction delayed and capital burning, hyperscalers are borrowing heavily to keep their operations afloat. Recently, operators issued $34 billion in new data center bonds to bridge their funding gaps. This chart shows the current interest rates for A-rated data center bonds. Despite being classified as highly secure investments, the yields are soaring into the 8 to 12% range. This disparity suggests that while the credit agencies still label these debts as safe, the market is pricing them based on the physical reality, the delayed openings, power shortages, and community resistance we have seen. Investors are demanding high premiums because they no longer trust that these projects will finish on time to pay back the loans. The risk is already materializing. Project Matador in Texas was heavily promoted as a 17-gigawatt AI megacampus. In less than a year, it failed to secure a single anchor tenant. Executive leadership resigned, and the company's valuation collapsed from $20 billion down to $3.4 billion. The rapid expansion of AI infrastructure relies entirely on the assumption that capital, land, and power are infinitely available. When those variables become finite, the financial math driving the boom collapses. The economic viability of these trillion-dollar sites depends on maintaining a high price for AI services. However, free, open-source models are now reaching 80% of the performance of the most expensive systems. If the end product of this hardware becomes a low-cost commodity, the massive sunk costs of the data centers become unrecoverable. To survive this incoming margin compression, the industry cannot simply build more concrete warehouses. The physical architecture of the data center must adapt. Developers in China are already testing subsea servers. By placing data capsules on the ocean floor, they utilize cold seawater for passive cooling, redirecting almost all electricity directly into computing power and completely bypassing strained terrestrial grids. Hardware manufacturers are also pivoting away from the cloud entirely. By expanding unified memory on local devices, companies are enabling smartphones and laptops to run complex AI models natively, eliminating the need to ping a distant, power-hungry facility. The technology will adapt. But as the current, centralized infrastructure bubble pops under its own weight, the physical footprint remains. The question is, who will be left paying the price for the altered landscapes and the permanently higher utility bills?